Hi, welcome to Algebra 2 Common Core. Today we're going to continue with Lesson 7, where we're going to practice some more systems of linear equations. We want to look at this system in exercise number 1, where we have three equations with the variables x, y, and z. I want to decide which variable is most appropriate to eliminate. In this system, it looks like it would be easiest to eliminate the z's because we have positive and negative z's that will cancel off when I go ahead and do addition. So I'm going to start by adding the second and the third equation together so that the z's will cancel. So adding those two equations, I'm going to get 5x plus 3y is equal to 11. I then need to pick a different combination of two equations that I'll add together. It would work out nicely if I take the first equation, so 2x plus 3y minus z equals 5. And I want to add that one also to the third equation, so x plus 4y plus z equals 12. When I add those two equations together, that's going to give me 3x plus 7y, notice that the z's are eliminated, equals 17. So I now have the blue equation and the red equation that both have the variables x and y. I need to decide next whether I should eliminate the x's or the y's. Either would be fine. I'm going to choose the x's. So if I'm going to take my x's and eliminate them, I have to make a 5x in the first equation and a 3x in the second equation. Both have the same coefficient. So I'm going to multiply the blue equation by negative 3 so that I'll get a negative 15 in front of the x. So taking this equation and multiplying everything by negative 3 will give me the new equation, negative 15x minus 9y equals negative 33. I'm going to take the red equation and multiply everything by positive 5. And when I do that, I'm going to get 15x plus 35y is equal to 85. So check your arithmetic there before we go on to be able to add together these two equations and cancel off my x's. So the x's are eliminated, and when I add negative 9y and 35y, that's giving me 26y is equal to 52. Divide both sides by 26, and I have my first solution, y is equal to 2. And I want to take that answer and substitute it into one of the two equations, either the blue equation or the red equation, so that I can then solve for the variable x. I think I'm going to take the blue equation, so 5 times x plus 3 times y, but now we know that y is equal to 2, is equal to 11. That gives us 5x plus 6 equals 11. Subtracting 6, I have 5x is equal to 5, so x is equal to 1. So there's our second solution. To find the y for this system, I just go back to one of the original equations and substitute the x and the y that I've just found. I think I'll use the third equation, but any of the three would give me the same exact solution. So in the third equation, x plus 4y plus z is equal to 12. I'm going to replace the x with a 1. I'm going to replace y with 2, so 4 times 2 is 8, plus z equals 12. When I add together, I get 9 plus z is equal to 12. So subtracting 9 from both sides, I get that z is equal to 3. So I now have all three variables solved for. And again, remember that we can write this solution set in alphabetic order, so 1 for x, 2 for y, and 3 for z. Now I would always take that solution and substitute it into the 3 original equations to be sure that we have an accurate solution. You can also do this on your graphing calculator by storing 1 for x, 2 for y, 3 for z, and then typing each of these equations into your graphing calculator to be sure that you get the number that's on the right side of that equation. Let's go on to the next example. In exercise number 2, don't let it confuse you, but this time we have the variables r, s, and u. Now the nice part about this equation is that the second equation has just 2 variables in it. And I notice, in fact, that if I add together the second equation and the third equation, I'm going to eliminate not only the s, but also the u. That will give me right off the bat the solution for r. Now, this doesn't have to be your first step, but this is definitely a very easy first step so that we're getting one of our answers already. Now I'm going to take that answer for r and I'm going to substitute it into one of the originals. I think I'll plug it into the first equation. So I now have 6 plus 2s minus u is equal to 8. Simplify that by subtracting 6 from both sides, so 2s minus u is equal to 2. Remember that now I can take my second equation and add that on, and I see that right away I'll be able to eliminate the u's. I didn't even have to go ahead and multiply by a coefficient in either of those equations. So u's are eliminated, and I get a new equation, 3s is equal to 6. Dividing both sides by 3, s is equal to 2. So I now have 2 of the 3 variables solved for. Go back to any of the original equations. I'm going to take the easiest one. S plus u is equal to 4. If I substitute 2 in for s, that allows me to solve for the u in my equation. So easily I get that u is equal to 2. So I have my solution like this. Now again, you can write your answers in alphabetical order as far as solutions. So r comes first with a 6, s comes second with a 2, and u comes last also with a 2. If you go back and substitute those values into any of the 3 original equations, you should get a correct solution. Now let's move on to exercise number 3. In exercise number 3, this shows us another application of solving 3 variables with 3 unknowns. So this one is telling us that we have an equation. Our equation, hopefully you recognize as a quadratic equation. So if we were to graph this with numbers in for a, b, and c, we should get the graph of a parabola. Now we don't know what the a, the b, and the c are this time. We want to be able to solve for a, b, and c, but we know that this point 16, this point 320, and this point negative 215 have to satisfy the equation of the parabola. So I'm going to take each point. In the case of the first point, 1, 6, I know that the 1 stands for the x-coordinate, the 6 stands for the y-coordinate. So in my standard equation of a parabola, I am going to substitute 6 in for y, and I'm going to put 1 in for each of the x's. So a times 1 squared plus b times 1 plus c. So we are setting up the system of equations that we'll need to solve by substituting the given point into the quadratic form. So this gives us 6 is equal to a plus b plus c. So there's our first equation in our system. The second equation will be based on using the point 3, 20. It works exactly the same way with this point. 3 is the x-coordinate, 20 is the y-coordinate. So in my standard equation for a quadratic, I'm going to substitute 20 for the y, and I'm going to put 3 in for the x. So a times 3 squared plus b times 3 plus c. This gives us 20 is equal to 9a plus 3b plus c. There's our second equation with 3 variables, a, b, and c. Now take a minute and use the third point, negative 2 comma 15, substitute it into your quadratic equation for x and y, and find the third equation that we'll need to use to solve for a, b, and c. Pause the video for a minute and come back and check your third equation with mine. Welcome back. Did you get the equation 15 equals 4a minus 2b plus c? If you didn't, check your work. I'm going to go to a clean slide so that we can now solve this system of 3 equations with 3 unknowns, a, b, and c. So here we have those 3 equations written down again. This time we want to be able to solve this system and be able to decide which variable we're going to eliminate. Clearly it's going to be easiest to eliminate the c's because we don't have any coefficients in front of the c's. So I'm going to take one of the equations and I'm going to negate it. I think I'll take the first equation and multiply through by a negative 1. The reason for that is because when I do that, I'll then be able to eliminate the c's with the other 2 equations. So this equation is going to become negative a minus b minus c equals negative 6. Now I'm going to go ahead and add that equation, negative a minus b minus c equals negative 6, to the second equation, 9a plus 3b plus c equals 20. Adding together my like terms, I've got 8a plus 2b equals 14 because the c's canceled. Now I'm going to take that very same equation, negative a minus b minus c equals negative 6, and add that to the third equation, 4a minus 2b plus c equals 15. Again, the c's are going to be eliminated because one's positive and one's negative. So I have 3a minus 3b is equal to 9. Now both of these equations can actually be reduced. The first one I'm going to go ahead and divide everything by 2. So I get 4a plus b equals 7. This is a very useful technique, simplifying equations, because then my coefficients aren't as big, and then I usually don't have to go ahead and multiply through by a constant to cancel with the other equation. The second equation, everything can be divided by 3, so I'm going to say a minus b is equal to 3. So if I line these 2 equations up underneath each other, the nice thing is the b's are going to be eliminated, so I now have 5a is equal to 10. Dividing both sides by 5, a is equal to 2 is the first answer. Now I want to use that value for a and solve for b. It doesn't matter which equation I use, so what if I say 4a plus b equals 7? So 4 times 2 is 8 plus b is equal to 7. So b turns out to be negative 1. There's my second solution for this system. Now, going back to one of my original equations, I think I might use that nice easy one, a plus b plus c equals 6. Substituting 2 in for a, negative 1 in for b, I can easily solve and see that the c turns out to be equal to 5. Now when I have a system like this, I'm not done when I get the answers for a, b, and c. I need to take those values for a, b, and c and put them back into my quadratic equation. So for the quadratic equation, I'm going to go back and say y is equal to the coefficient a goes in front of the x squared. The coefficient b goes in front of the x, and c becomes my constant. So this is the solution to this problem. We have found the quadratic equation that satisfies all three of those points. As long as we have 3 points on a parabola, it defines a unique parabola. Now what I'd like you to do is pause the video and go put this quadratic into your graphing calculator. Then press the trace key and go through your 3 points that we were originally given, 1, 6, 320, and negative 215. Make sure that this parabola satisfies those 3 points. We're going to do a lot more practice with this new method of solving for a quadratic equation when we are in class again together. Thanks. Have a great night.